Let's go ahead and review our work from yesterday, whether you finished it in class, excuse me, or at home. Go ahead and have that out on your desk so we can look at that together. We're on page 426 in the textbook. If you want to have that out. And your figure that was given to you in the book, I've got over here kind of blown up a little larger so we can see that a little bit better. All right, so for number 14, you're given that zy, so your top side length is 2x plus 3. Your bottom side length, wx, is x plus 4. And they want you to find the length of wx. And for me to find this side length, I first have to know what the value of x is. So I have to find some way to relate these two expressions to one another. And well, since this is a rectangle, I know that opposite sides are congruent, meaning that 2x plus 3 is equal to x plus 4. And so then I can solve for x here and get that x is equal to 1, and then plug that in right there into the expression that represents the measure for wx. And so your length of wx would be 5. All right, number 15. Now we are given that py, so from the middle to one of the vertices is 3x minus 5. And I'm also given that WP is 2x plus 11. And then I'm asked to find ZP. Okay, well, first of all, you have to know that these two measures, the 3x minus 5 and the 2x plus 11, are congruent. I know this because this is a property of a parallelogram, and a rectangle is a parallelogram. So this is the relationship that's going to allow me to solve for x. Okay, then I also know that this whole piece from wy is congruent to this whole piece from z to x. And so if the two wholes are congruent, then when I bisect those two whole pieces, then their resulting pieces would also be congruent. So in this case, all of these are congruent to one another. So if I can find the value for x, that's going to allow me to find the measurement of any one of these four pieces making up this little x that goes in the interior of my rectangle. And so my first order of business is I have to find out what x is. And so let's subtract 2x from both sides and add 5 to both sides. It gives me x is equal to 16. Now it doesn't matter which one of these I plug into because the measurements of all of these is going to be the same. Okay, so the expression containing x might be different, but the value that you're going to get out of it once you plug in 16 for x is going to be the same. So I'll just do this one here, plugging in 16 for x. 2 times 16 is 32, plus 11 is 43. Okay, now that's technically what I just found is the measurement from W to P. But we talked about the fact that all four of these are the same. So if I find one of them, then I found all four of them. Okay, so this is WP, but it's also ZP, which is what you were asked to find in the problem. Okay, number 16. Now I'm looking at angles instead of side lengths. I've got angle ZY, ZYW. Okay, so from there to there. That's my angle that is given as 2x minus 7. Then I have WYX, so this angle is given as being 2x plus 5. And what you're asked to find is ZYW. So they give me an expression for both of these and then ask me to find the measurement of ZYW. To find that measurement, I have to first know what x is. So I have to find some way to relate these two expressions to one another. Well, you'll notice here you have two angles that share a common side here. So if I add these two angles together, I know what I'm going to get. Because this is a rectangle, I have 4 right angles. So this angle plus this angle will give me 90 degrees. That is my relationship that's going to allow me to solve for my variable. So I say 2x minus 7 plus 2x plus 5 is equal to 90. And then just solve this equation. You've got 4x minus 2 is equal to 90. And from there we've got 4x is equal to 92. So then x would be equal to 23. And once you find your value for x, you take that and plug it in right there, because that's the measurement you were asked to find. Okay, so the measure of angle ZYW is equal to 2 times 23 minus 7, which ends up being 39 degrees. And number 17, now we're going back to having side measures given, or segment measures given. ZP is equal to 4x minus 9. PY is equal to 2x plus 5. And I'm asked to find ZX. And we talked a little bit earlier about the fact that in a rectangle, all of the pieces here are congruent to one another because they're the whole diagonals themselves are congruent, and then the diagonals bisect each other. Okay, so you've got 4 congruent pieces here. That's going to allow me to solve for x, because I know that 4x minus 9 is equal to 2x plus 5. All right, there's your relationship that allows you to solve for x. Now once I find x, I can get this measurement by plugging that back in, and then I'm going to have to double that since these two are the same. So subtract 2x from both sides, add 9 to both sides, and x is equal to 7. Okay, now I take my x is equal to 7 and plug it in right here in this expression. So you have 4 times 7 minus 9. That's 28 minus 9 is equal to 19. And that was ZP, and you're asked to find ZX. Okay, well, ZX is twice what ZP is. So ZX has a measurement of 38 units, or just 38. Number 18, back to angles here. '18 says that the measure of angle XZY, so XZY would be this angle right here, and it is defined as being 3x plus 6. All right, and then angle XZW is defined as being 5x minus 12. So this angle 5x minus 12, this angle 3x plus 6, and I should put another one here because these are not congruent angles. Then they want me to find the measure of angle YXZ. This one is a little more complicated than the ones we've looked at thus far. So this is the angle in question. So the first thing that I'm going to do is I'm going to solve for x because I know that these two are complementary, because I know that this is a 90-degree angle. I'll be able to solve for x fairly easily. And then we'll talk about how we're going to use that information to find this angle over here. And so first of all, solving for x, I have 3x plus 6 plus 5x minus 12 is equal to 90 degrees. Combine your like terms. Add 6 to both sides. Divide by 8. Okay, so x is equal to 12. I'll put that information right up here. Okay, that's first and foremost, I need to know what x is. Okay, that way I can go back and find actual angle measures for these two angles here. Okay, so how do I take the given information and relate it to the angle that I'm asked for? Okay, well, one of the characteristics that exist for a rectangle is that opposite sides are parallel, because this is a parallelogram. So I know that ZY is parallel to WX. Okay, so if you take this diagonal out of the equation, and if you take these two sides out of the equation, and you visualize only ZY, WX, and diagonal ZX, okay, well, these two lines can be extended in both directions,